We're going to take a look at finding a molecular formula. Now, up to this time, we have found empirical formulas. So everything we've done up to this time, you had it on your quiz. We've had it on assignments where you're given percentages, and you find a empirical formula. Now, empirical formula means it's the simplest ratio between those elements that are combined. And if you remember, I gave you an example of that. We're going to kind of use that example here. So I'm going to give you 2 bits of information, and we're going to go through and give you 2 steps to figure out the molecular formula with this information. Okay? First of all, when you go through, take percentages, you'll eventually come up with an empirical formula, like our lab we did. Magnesium and oxygen. You were supposed to take those weights, change them to moles, and find the molecular formula, or the empirical formula. Okay? The empirical formula in this example, which maybe we went through the steps and we came up with this empirical formula, and we came up with the formula that says CH2O. So that's our empirical formula. We went through the steps, boom, divide by the smallest number of moles. We came out to be 1 to 2 to 1. We wrote our empirical formula, right? So we're picking up from that point, and we're trying to see what the molecular formula is going to be. To be able to find the molecular formula, you've got to know the molecular mass of the molecular formula. So I'm going to go ahead and give you the molecular mass.
Or you just add them all up, right?
Not in this example, but I need to give you the exact quantity. Okay? Because they're going to be different. Because the molecular formula is going to be different than the empirical formula. They're going to be different. It's going to be the same ratio, but higher numbers. Okay? So, for this molecule, we're going to go ahead and give you it. It's going to be 180.18 grams per mole of molecules. Okay? Now, if you look at this weight here, if you look at this weight, or this formula, if you add those all up, you're not going to come up with 180. So right there, you can look at that and go, there's some extra steps I'm going to have to do to find a molecular formula. The first thing I'm going to have to do when doing this is I'm going to have to find the empirical formula mass. So in our example, we have CH2O is our empirical formula. So find the mass of that. Find the empirical mass of CH2O. So you have to have your periodic tables out to do that. So carbon is 12.01. And 2 hydrogens is 2.02. And oxygen is 16. I just set it up that way. It doesn't really matter. And so when we add everything up, we get 16 and 2 is 18 and 12 is 30. So we get an answer of 30.03. Right? That's empirical mass. If we go back to our original setup, here's the molecular mass. The molecular mass is going to be a multiple of whole numbers higher in weight compared to the empirical mass. So it's kind of like our water hydrate lab that you did. It was always a multiple of 2, 3, 4, 5 higher. Okay, in moles, for example. But this is in weight. So what we'll do, our second step is real easy. What we're going to do is take the empirical mass and divide it into the molecular mass. So that's going to give us our multiplier. So molecular mass, and that's one you'll be given in all the problems. So anytime you're given a molecular mass, you realize you're going to have to find the empirical mass in which to see the difference between the two. That's going to give us what we call X. X is that multiplier. So we're going to take the 180.18 grams, and then we're going to divide by the 30.03 grams. And when we do that, we get a number that is 6. Any questions on that?
Do we round it, or is it always going to be?
Yeah, it's always going to be a whole number. It's going to be really, really, really close. Now, some of you on your labs, you don't, or even on assignments, you don't take significant digits out maybe as far as you should. And that would get you in trouble because sometimes you'll come up with a number that won't be as close to the whole number as it should be. And then because of that, you'll have some questions like, did I do this right? It doesn't look right. But it should get really close to a whole number. So that becomes our multiplier. X is our multiplier. And so our formula we had was CH2O. So if we multiply everything in there by 6, then our subscripts become C6H12O6. So that number will be our multiplier that you're going to use. That makes sense? So here's the deal. We'll have students that can do empirical formula. Boom, they can do it. They get them all right. But when it comes to finding the molecular formula with these two steps, they're not sure kind of where to go from there. So we're going to give you a simple one to do to practice. Okay? And then a tougher one to do to practice. All right? We got a simple one, a tougher one, and then I'll give you an assignment to do. If you look on page 249, which is the next page over, and we're going to have you do number 1. Number 1, exactly the same as what I did my 2 steps here. 1 and 2. You're going to do the same 2 steps. It should take you about 2 minutes to do. So, practice problem is the one that has the red border lines. We're going to do number 1. Go ahead and do number 1. See what you get. The empirical mass is 13 grams. Or AMUs. If I use grams or AMU, they use AMU as per molecule. If it's grams, it's per molar molecule. So sometimes you can say grams, sometimes you can say AMU. The only difference is AMU is relative mass of molecules, and grams is the weight of 1 mole of molecules. Okay? So we take the molecular mass divided by the empirical mass, and the number goes in 6 times. So then that's our multiplier. So 6 on the outside of CH. Our formula is going to be C6H6. Questions? Easy? Yes. This is called benzene. If you're in organic chemistry has a different naming. It can get pretty tough, but that's called benzene. Okay? Is what that would be. It's a cyclic structure. It's kind of like, it's a hexagon, carbons all connected in a hexagon with hydrogens off, with some multiple bonds and then hydrogens off of that. So, not that you need to know that. Next one, you got to combine steps now. So, you need to look at problem number 2, under 1 you just did, and you need to complete that problem, but the only thing is with number 2, you have to find the empirical formula with the weights. 0.44 grams of hydrogen and 6.92 grams of oxygen. So, right, look back at your notes. I've had students in last class, they said, I don't know how to do this. Yeah, you do. Okay, look back at your notes. It says change percents to grams. Well, these are already in grams, so you don't have to do that step. And then change grams to moles. Compare the moles. Come up with a mole ratio. That mole ratio then becomes your empirical formula. Once you have that, then you have the same information as you do number 1. So do number 2 on page 249. Look at the setup. The first thing we have to do is change grams to moles to find the exact number of moles so we can compare the relative number of moles. And if you notice, basically they're the same number of moles. So then our formula for empirical formula is HO. That is our empirical formula. So now that we've done that step, we are now at the point what we did today for practice. We would take the molecular mass divided by the empirical mass. So HO is our empirical formula.
You just have it.
Yeah, I know. HO is our empirical formula. And so it would be 1.01 plus 16 is going to give us 17.01. 34.0 divided by 17.01 gives us 2. So then with the 2 is our multiplier, that's x. That's what we're going to go ahead and take HO times 2, and that would be H2O2, and that's hydrogen peroxide. So the steps we would go through, and this is a pretty simple problem because we're just dealing with oxygen and hydrogen, and so it's pretty easy ratio to figure out. Any questions on that? Right. What I'd like you to do, problem-wise, then, is to do problems 38 and 39. On page 253 for tomorrow. And then I'll also give you out this review, which you can start working through now if you want to.
So